This is a song about calculus, related rates more specifically, and a anecdote about a sine wave. Kind of a love story, if you will.
A lonely sine function has not much to do but oscillate at a steady pace and talk of it to you. And there'd be too many tangents if I tried to relate the vectors of our attitudes in differentiated rates. The triangles formed by our relationships made are similar in terms of all the angles they gave. Both you and I still function as each second passes, and we keep on intersecting at the x-axis. I said you must be sinusoidal, and she winked her lashes. It was a sign, she was a sign, I could almost see the graphic. I was positive to start, but now my slope's on the down. Then I saw her again and relinquished my frown. Her slope was on the rise when I realized that her eyes and features looked very comparably derived. Examination proof she was derived from my bro. His name's cosine and he's kinda cool and really practical. But anyways, I determined that my love and I were just inverted versions of each other, and it hurt me to admit it as we crossed our paths again. Our love affair was affable but coming to an end. She was a negative sign and she neutralized my weight like Poppins and X-bars on a sunny summer day. We perpetuate the time for our predictable pattern to repeat. Our time just wouldn't last, at least in terms of sound. We'd constantly be making noise to cancel each other out.
Destructive interference.
Now let's flash to a specific case. A spotlight moving towards an actor singing on a stage. Assuming the rate of radial rotation is constant, at what point in time does the light reach a subject? Following just a couple simplistic rules, we can calculate with calculus using algorithmic tools. Although it's impossible to disregard chains, we can still use other formulas to manipulate. Pythagoras was right when he proved that the squares, three sides were more than just triangular pairs.
Bye, Danny.
Whoever thought the magnitude of this little proof could become the cornerstone of our trigonomic use? And it doesn't really matter which direction we choose, just as long as we know the rate and one constant value.
So basically, just
Give me a point in time for which I should solve. Use our Greek friend's trick and confusion dissolves. Deriving his theorem, it's now easy to see that the only unknown is d something dt.
But wait!
Don't forget you must include the context, requiring a sentence in which we express the forwards, backwards, increase, decrease, plus or minus, and all units.